Hello guys, now we are moving on to lesson 1-5, adding and subtracting real numbers. Here is our objective. We want to find the sums and differences of real numbers. I put this on here just to remind you. Remember, real numbers, you can break them down into the rational numbers and the irrational numbers. These are the numbers that we're going to focus on with this. The rational numbers, those are the fractions, the decimals, the terminating ones, the repeating ones, and then the whole numbers and the integers. So first, let's look at the Getting Ready box on page 30. It says, you have kept track of the activity on a gift card, as shown at the right. The values are negative red when you spend money and positive black when you add money. You want to give the card to a friend. How much money must you add to make the card worth $25? Explain your reasoning. So we're going to start doing adding and subtracting positives and negatives. So let's just see what we have. We start with $50. And then when we buy a new game, we're going to subtract 19. So let's see. Let's do this one piece at a time. 50 minus 19 would be 31. And then we buy a new jacket. So we're going to subtract another 29. 31 minus 29 would be 2. And then Aunt Sue adds $25. So add on another $25, and we're at 27. Okay, I'll put the 27 over here again. And then we buy new headphones, so we're going to subtract 13. So we have 14 left. Okay, we have $14, and you want to give this gift card to your friend, which would have $25 on it. So how much do we need to add on to this so that our total is going to be $25? It looks like if we do 14 plus, well, you could work backwards. You could do subtraction. I guess you could do 25 minus 14, and that would be 11. So 14 plus 11 is how you get 25. So how many do you have to add on is 11. All this was really wanting you to do is just to kind of see, oh yeah, make sure you make it $11. Put a dollar sign there. Just so you can see, like, you're adding numbers, you're subtracting numbers. So this lesson is just adding and subtracting, working with positives and negatives. And as you're going to see towards the end, hopefully you realize that subtracting, so this very first subtracting, this is the same as adding on a negative. So we could have done this whole problem with adding, and we could have just added on negative numbers. Instead of subtracting, we could have just added on negative numbers. But right now that might be confusing, but hopefully at the end, that's what you realize subtraction is. So it starts off pretty easy. Problem 1 is adding and subtracting integers using a number line. And I know you did this in 7th grade, so we're not really going to do this ever. Like, I'll never have you make a number line, but it's good. It's easy to start with, to kind of wrap your head around which direction you're going. So when you do this, and you can always make a number line if you want to. The first problem is 3 plus 5. So you put a dot at 3, and then you add on 5. So you're working your way 5 up. So 1, 2, 3, 4, 5. And you end at 8. So 3 plus 5 is 8. And you shouldn't need a number line to do that. Now, 3 plus negative 5. So we start at 3. Now, negative means you're going backwards, like you're going the opposite direction. And in terms of a number line, negative means we want to go to the left. So we go to the left 5. 1, 2, 3, 4, 5. And you end at negative 2. So 3 plus negative 5, you have to make sure that when you do negatives, you're actually working backwards. And anytime you're working with positives, you're going forward. This one, part C, we start at negative 3, and we want to add 5, so we want to make sure we go this way. 1, 2, 3, 4, 5. You end at positive 2, and negative 3 plus negative 5. So you're going to start at negative 3. Now, even though it says add, you're adding on a negative number. And negative means you have to go to the left. So 1, 2, 3, 4, 5. So you end at negative 8. Hopefully you noticed something here. Anytime well, maybe we'll save that for later because I don't want to get too far ahead of myself and confuse you. So that's how you model it with a number line. I'm never going to ask you to do this. We have rules for these, and anytime you have like two positives or negatives, and we're more going to follow the rules, and hopefully we're soon able to do these in our head. But I just wanted to show you that's how you would do it with a number line. Here is our vocabulary, and then there's a little bit more later on, but absolute value, hopefully that's something you remember from last year. Absolute value is just the distance a number is from 0 on a number line. The easiest way to remember this is the absolute value, it always becomes positive because a distance always has to be positive. Like when you're walking, whether you're walking to school or from school, it's two different directions, but the actual amount of steps you take would be a positive amount. So here are our examples. The absolute value of 4 equals 4. Because here's 4, here's 0, this distance is 4. It could be 4 miles, 4 feet, but for right now it's just units, so it's just 4 units. And then the absolute value of negative 4 is also 4. Here's negative 4, here's 0, and this distance right here, even though it's on the negative half of the number line, is still 4. So an absolute value is always positive. And you're not really going to have to take the absolute value of numbers, but it's more that they're going to use this term in explaining the rules. So that's all. Okay, adding rules. There's two of them because we have two different cases. If the signs are the same, so there's a positive and a positive, or a negative and a negative. If the signs are the same, add the absolute values and keep the common sign. So 3 plus 4, that's easy, but what you really did was the absolute value of 3, the absolute value of 4, and the absolute value of 3 is 3, the absolute value of 4 is 4, and then your answer is 7. Now, because both of those numbers started as a positive, your answer is a positive, and you don't have to write the plus sign. If you want to double check yourself, you can, but a positive, you just write it as a positive. Now, if you have negative 3 plus negative 4, you still get 7. See how both ways we get 7 and 7, because the absolute value of negative 3 is 3. The absolute value of negative 4 is 4. So you're still doing 3 plus 4, but this time, because they were both negative to begin with, your common sign is negative. So your answer would just be a negative number. Okay, so if the signs are either both positive or both negative, you add the absolute values. You can kind of think that because they're the same, you're trying to combine them, and then if you have negatives, you just have more negatives, so you want to add. If we have different signs, so if you have different signs, you subtract the absolute values. And now here's the problem. One's a positive and one's a negative. So which do you keep? The positive and or the negative? You keep the sign of the bigger number. Sometimes when people really have trouble with this, I tell them to think of it like this. So negative 3 would be represented with 3 negatives. 1, 2, 3. Positive 4 would be represented with 4 positives. So plus sign, plus sign, plus sign, plus sign. Every time you have a negative and a positive together, they will cancel each other out. And then what's left over is 1 plus sign. So that's why your answer is 1, and it's positive 1, because you had more positives than negatives. So if you do it by the rules, what you're doing is subtracting the absolute values. So what we're really doing is taking the absolute value of 4 minus the absolute value of negative 3, which is just 4 minus 3, which is 1. And because the bigger number was a positive, you keep the positive. And when you subtract, I know it was negative 3 plus 4, but when you subtract, you don't do borrowing with this, so you always just put the bigger number first. Okay, if we had negative 3 plus 4, well, let me show you with my pluses and minuses. 3 positives, 4 minuses, and this time, every time you have a plus and a minus, they cancel out. So you have 1 left over, but this time it was a negative because 4 is bigger than 3 and the negative's on the 4. So if you do the absolute values here, you have negative 4 minus the absolute value of negative 4 minus the absolute value of 3, which is going to get you 1. and you got to make it -1 because the sign was bigger. The reason that they have you do absolute values is because you can do that in your head. You don't have to write this down. Most of the time for these, there isn't going to be any work you're going to show because you should be able to do the absolute values in your head. If you want to write this stuff down, you can, but you don't have to. There is a song. Mrs. Hiltz actually made up this song. You sing it to the tune of Row, Row, Row Your Boat. And I'm not a very good singer at all. I apologize for this. But I just want to... Sometimes you have these catchy little songs. They get stuck in your head. So if you want to sing the song, you can. It goes, same sign, add and keep. Different sign, subtract. Keep the sign of the bigger number just to be exact. So if you sing it over and over, I mean, that's all it's saying is if they have the same sign, you add and you keep the common sign. If they have a different sign, you subtract them. Well, you have to keep the sign of whichever one was bigger, and then the just to be exact, I think that's just thrown in there to make it rhyme. So, if you remember the song, it seems to help a lot of people. If not, then you can just remember the rules. Okay, problem 2. So, let's try these. The first thing you want to do is decide, are they the same or are they different? So, for part A, we have -12 plus 7. Those are not the same. Those are different because you have a negative and a positive. So if they're different, that means you're going to subtract. So in my head, but I'll write it down, I'm going to do 12 minus 7 because I already took the absolute values in my head. 12 minus 7 is 5. Now, is it positive 5 or negative 5? The negative was on the 12, which was bigger, so your answer is -5. Okay, part B. -18 plus -2. Those are the same. These parentheses here, those don't mean multiply. You don't really want to have -18 plus a -2. You don't have two symbols like that with nothing separating them. So a lot of times, if the negative number comes second, they'll just put it in parentheses. Sometimes you'll see that and sometimes you won't. If I'm typing it up, you'll see it like that, but sometimes if you're looking at things on the internet, sometimes they will just write it like -18 plus -2. And you would just know that this could be in parentheses. Okay, so they're the same. So in my head, I'm going to do 18 plus 2. That gets me 20. Now, because both of these started as a negative, it's a -20. I think a lot of this stuff you can do in your head, but when we get to decimals, it's a lot harder to think of 4.8 and 9.5 in your head. Like, you can't visually see the number line. So first we want to decide the signs are different, which means we're going to subtract. So I'm going to take 9.5 minus 4.8 because I just did the absolute values in my head. So when I do that, and you have to borrow, I get 7, you get 4.7. And then you have to decide, is it positive or negative? My bigger number, 9.5, was positive, so overall I have more positives than negatives. And think, if you were to write them out, now I know you cannot write out 9.5, but even if you wrote out 9 and 4, you have 9 positives, and you have 4 negatives, and you clearly have more positives than negatives. So your answer is 4.7. And then the last one, because we always have to have a fraction. So the signs are different, so we're going to subtract. Make sure you get common denominators. So right now, looking at this, you might not know which one's bigger, so let's just change them. The common denominator is going to be 12, so let's change them both into 12s. 4 times 3 is 12, so 3 times 3, that's 9 out of 12. 6 times 2, so that's 10 out of 12. So think in your head. Take the absolute value. So we're going to do 10 over 12 minus 9 over 12. That gets us 1 over 12. Now, which one was bigger? 10 over 12 was bigger. That's why we started with that one first. And that was the one that had the negative on it, so our final answer is negative. Alright, got it, number 2. I threw this in there. This is what helps me. I know it's a little bit of a shortcut, but I think same, sum. They both start with S. Different and difference both start with D. I don't like to give you too many shortcuts. That's why I didn't tell you that at the beginning, because I want you to understand that the whole absolute value thing, but once you get past that, if you can remember same, sum, different, difference, I think it'll help out. So part A, these are the same, so I'm going to add them. 16 plus 8 is going to equal 24. Whoops, sorry. And now because they both started as negative, your answer is negative. I see so many people, and I know why, because when we get to the multiplying, the rule is completely different. When we get to multiplying, two negatives make a positive. So if this was multiplying, this would be a positive answer. But when you're adding, if you take a negative amount plus more negative, how can that come out as positive? So be very careful when you're adding, two negatives make a negative. Alright, part B, different. So I'm going to subtract. 11 minus 9 equals 2. And then whichever one was bigger, the negative 11 was bigger, and that had the negative on it, so it's a negative 2. Part C, different. Again, I have to do 11 minus 9 and I get 2. Again, the negative was on the 11, which was bigger, so your answer is negative 2. And part D, the signs are the same. So I'm going to add 6 plus 2, that's 8, and you want to keep the common sign, which is a negative. So your answer is negative 8. This one was negative 2. Okay, a little more vocabulary. Now, you have to be very solid with those two rules because in order to subtract, you just change it to an addition problem. So a couple vocabulary things. Opposites, numbers that are the same distance from 0 on a number line. So you should know this. Here's 3, here's negative 3. Those are both 3 units away from 0. 5 and negative 5, those are opposites. Those are both 5 units away from 0. And negative 3, negative 1.3 and 3. So one's positive, one's negative. Then we have this inverse property. Now I'm never going to ask you to say what is the inverse property of addition. You just kind of need it to know how to do subtraction. So it says for every real number A, there is an additive inverse, negative A, such that if you take A plus negative A equals 0. All that's saying is any number plus its opposite equals 0. If I took 5 plus negative 5, that would equal 0. If I took negative 6 plus 6, that would equal 0. That's all that's saying. Okay, and we have one subtracting rule. To subtract a real number, you add its opposite. So for this problem right here, 3 minus 5, it's kind of like the keep, switch, flip you do when you divide fractions, but it's not fractions, it's a little different. You add its opposite, so you keep the first number, which was a 3. Now, this is the subtraction symbol, and that's your key to think, okay, add its opposite. So that becomes an add, because you have to add, and then you take the opposite of what comes next. So that was the subtraction symbol, and your number is a 5. So what's the opposite of 5? That becomes negative 5. Okay, and that's all they have right there. And then you follow the adding rules. So the signs are different. I'm going to subtract. 5 minus 3 is 2. The bigger number was on the 5, so it's a negative 2. If I have 3, now here's my subtraction. That's my cue. Change it to add. Now here's my second number. My second number is a negative 5. The opposite of negative 5 is positive 5. And 3 plus 5 is 8. I don't know if they showed you this last year, but this is kind of, and again, this is a trick, but if you understand it, two negatives when you're subtracting, and I can show you, it's easier if I show you this in person, but if you swing this around and make it a plus, subtracting a negative will always become plus. So if you had 6 minus negative 8, that just becomes, like some people just go like this, plus plus, and it just becomes 6 plus 8. Anytime you're subtracting a negative, it becomes plus. So let's try these. What is each difference? So remember, you're going to add the opposite. So you start with negative 8. There's the subtraction. That's our cue to add. And then the opposite of negative 13 is positive 13. And now you just follow the adding rules. So the signs are different. We have a negative and a positive, so I'm going to subtract. I can do that in my head. 13 minus 8 is 5. The bigger number was 13. It was a positive, so my answer stays positive. Okay, 3.5 minus, so that's our cue to add. Now, this was the minus. The number is 12.4, so we want to add negative 12.4. So the signs are different, so we want to subtract 12.4 minus 3.5. Of course, every problem you have to borrow. That's going to be 9, and that's going to be 8. 8.9, and the bigger number was 12.4. It had a negative on it, so our answer is negative 8.9. And now 9 minus 9, you should know. That should be 0, right? Well, let's see if it works with the rule. So it's going to be 9 minus, then our number was 9, so we need the opposite of 9. Oops, sorry, this becomes 9 plus negative 9. And when you have a positive and a negative, you subtract. Well, 9 minus 9 would be 0 anyways. Alright, got it, number 3. So what is 4.8 minus negative 8.7? Remember that trick I showed you about minus minus? It just becomes plus. But let's follow the rule. So it's going to be 4.8. Subtract. That's our cue to add. Now the opposite of negative 8.7 is positive 8.7. And now we have two positives, so at this point, don't overthink it. Just do 4.8 plus 8.7. 15, and then 9, 13. 13.5. Okay, and part B, this is a reasoning. For what values, so you have to pick values of A and B, would A minus B equal B minus A? We might have done this when we did the commutative property. Remember in the commutative property you can do A plus B and then B plus A, and it's the same thing, but it doesn't work for subtraction. But there are certain cases it would work for. Think about which numbers A minus B would equal B minus A. I know which ones they are, but I want you to think about it before I tell you. Here's one I can think of. If I did A equals 4 and B equals 4. So 4 minus 4 would be 4 minus 4. 0 equals 0. If I had A equals 10 and B equals 10. 10 minus 10 would equal 10 minus 10. 0 would equal 0. So it's going to be any time that A and B are the same number. As long as A and B are the same number, they're going to be the same. If A and B were different numbers, they would just be off by a negative. That's all. Okay, and we have two word problems here. So problem 4, adding and subtracting real numbers. A reef explorer dives 25 feet to photograph a brain coral and then rises 16 feet to travel over a ridge before diving 47 feet to survey the base of the reef. So here's what I do. I draw a little line. This is sea level. Okay, so let's go through that again. He's going to dive 25 feet. That's going to be a negative 25. He then rises, so he comes up 16 feet. So that's going to be plus 16. And then before diving again, 47 feet. So that's going to be a minus 47. And then the diver rises, so he's going to come back up 29 feet. Now I'll just put it over here. To see an underwater cavern. What's the location of the cavern in relation to sea level? Now, one thing you can do, you can use the commutative property here, and you can group your negatives together and your positives together. So you can do negative 25 plus negative 47 plus 16 plus 29. And now remember, two negatives, when you add them, you're still going to be negative. So 25 plus 47, let's see, 5 plus 7 would be 12, carry the 1, it'd be 6, 7. So we've gone down a total of negative 72 feet. We've come up 16 plus 29 would be, that'd be a 15, carry the 1, would be 45. So overall, we're definitely negative because we have more negatives than positives. And now we're adding these. We're still adding all these up. But remember, if we have a negative and a positive, that's different. So we have to find the difference. So let's do 72 minus 45. 12, 6, 7, 27. And it's negative because the bigger number was negative. So what's the location of the cavern in relation to sea level? Negative 27 feet, which means you're 27 feet below sea level. So somewhere down here, 27 feet. Got it, number 4. A robot submarine dives, so let's do the same thing. Here's sea level. I guess I don't need the arrows on the end, but here's sea level. Okay, he's going to dive 803. So that's going to be a negative 803. It rises, and this is a submarine, so it's going up and down itself. It rises 215 as the water gets shallow. Then the submarine dives another, so that's a negative 2619. I'm going to fix that. 2619. Into a deep crevice. Next, it rises. So add on 734 to photograph a crack in the wall of the crevice. What's the location of the crack in relation to sea level? So if you had a calculator, I would just put in negative 803 plus 215 minus plus, and then hit equals and get your answer. But we're trying to learn how to do this without calculator. So I'm going to group together my positives, and I'm going to add them. 215 plus 734, and I'm going to get 949, and that's a positive. Then I'm going to group together my negatives, and I'm going to take the absolute values in my head, and I'm going to add them together because the signs are the same. So I have 2619 plus 803. That's a 2. That's a 2. 6 plus 8 is 14. And that's a 3. And now you have to keep the common sign, so this is a negative. And now we're trying to add negative 3,422 and positive 949. The signs are different, so we have to subtract. And I always run out of space. So let's subtract and start with a bigger number. 3422 minus 949. Subtract that. I do all my borrowing at the beginning, so that would be 3. That would be 7. That would be 4, and that would be 2. And then you have to decide if it was positive or negative. This is clearly the bigger number. It's got a negative on it. So what is the location of the crack in relation to sea level? It's 2,000. I mean, it's negative 2,473, but you could say 2,473 feet below sea level. Okay, so that's technically your answer. 2,473 feet below sea level. And that's it. Good job.